Hey everybody, this is Larry. This is day 10 of the Leetcode Daily Challenge. I'm back in New York just to give heads up. I don't know if you care, it's fine. But hit the like button, hit the subscribe button, let me know what you think, let me know your thoughts and all that stuff in general. Let's get right to it. Search insert position. Given a sorted array and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You may assume no duplicates in the array. Okay, cool. So this is another way of just saying, given a number of, given a target, find and there's no duplicate array, so there's no duplicates in the array, so find a number in which it is bigger than all the numbers smaller than it, right? So in this case, it is 2. 2 is smaller than all, or sorry, 2, all right, so in this case, it's 5. So the 2 means that for index 2, all the numbers to the left of that is smaller. So we just have to do that. And given that the array is sorted, you can do binary search, as you could probably predict. And if you practice, then that's good. And for me, I always have issues with by one and stuff like that. So let's go through it together. Let's practice it together. I also want to point out, though, that in a lot of languages, in C++, in Python, and probably even Java, I'm not sure about that one. I think there's an arrays.binary sort or something like that, search. But in any case, my point is that in a lot of languages, there is a built-in library for this. But of course, if you're practicing for interview and you're practicing binary search in general, it's good to kind of do it, because for competitive programming, you're going to have to binary search for something that you cannot just plug it into a library sometimes. So it's good to get that practice on. It's good to practice kind of where your edge cases are and stuff like that. So I'm going to do that here because I sometimes still make those mistakes sometimes. So yeah, okay. So now, so let's just, so there are a lot of so there are a lot of variations is what I want to say, which is that it depends on, and that determines how you write the code. So let's just write it down here for me. Target, find the smallest index in which target is greater than all the numbers to the left, or the smaller index. Is that true? Because I just want to make sure that okay, so if I just wanted to see what happens if, like, for example, 5 and 5. So technically, if it's just Leetcode, then you can just do it. Yep. Yeah. Then I always write my stuff the same. You have to figure out how you like to write it. And what I mean here is that usually the head will be 0, I guess, because it's usually very inclusive. You may come up with cases where it isn't, but that's just my reaction. And my tail, which is my second half, it is exclusive, meaning that this element is not going to ever be a real element, right? And I make that distinction slowly and deliberately because I think a lot of where I make mistakes with binary search is these off by ones, right? These off by one, so you have to define exactly what your things are. In this case, it's just inclusive, meaning zeros in our range, and then here this is just n, and in our case, n is not in our range, right? Because n minus 1 is the last index, so that's exclusive. So that's what I mean. So let's do while head is less than 2, mid is equal to, and there are a couple of ways to write this, getting the midpoint. I just write it standardly. I know there's an overflow issue and stuff like that, so depending on your language, you may have to think about it. In Python, it's okay, and in this case, n is not going to be bigger than overflowing range anyway. And here, sometimes I see people do this thing where they do if mid is equal to target, return mid, and that's fine. But I think depend on what you're doing, but for me, it just kind of, it helps to be just do it, keeping it binary so that I keep it stupid simple for myself. Your mileage may vary, so do it for yourself. And here I'm just trying to help myself visualize. So let's say you're giving the array, and then let's say our mid is 5, right? What does that mean? Well, if the mid is 5, that means that the search is over, but so maybe this is not a great example, but let's search for a 2 first. 2, let's say this is mid. Well, if this is mid, then we know that it is going to be to the left of mid. So we can do that. Okay, if nums of mid is greater than target, then we want to move the tail to mid so that it just keeps track of the left part, right? So tail is equal to mid, else head is equal to mid. Well, otherwise, what's the other case, right? If the other case is 1, if we search here, then we want to keep the entire thing. No, the other way, right? Maybe this is a bad example. But let's just say you have 1 and you have 5. Well, in this case, so the other way around, 6, right? And we do 3. Well, in this case, we want the head to be exclusive of 3 because wait, do we? No, we want head to be inclusive of 3. Yeah. Because if it's smaller, then it's still going to be true, right? Because in theory, like, let's say your number is 4, then you still want to keep the 3 because, well, that number is not going to be the case for 5. Okay, so those are our 2 cases. What about the equal case, as we said? Now that we have a better pattern, I guess it doesn't really matter. Because if it's equal, then as long as we're consistent, well, we want the mid still to be in it. So in this case, because our head is inclusive, we'll just put on the head. So if it's equal, it should be going through the head, and that should be okay. So that's our cases. And we also, because this will never converge because they're both on mid, then I just wanted to make this so that it goes to the +1 side. Okay, so now we just have to return head. I think that's it. And let's put on the other test cases while we wait. Time limit exceeded, so maybe I do have still an issue. That's okay. But let's. It's still going to be time limit exceeded. So why is it time limit exceeded? Well, because head and tail will never merge because we always take the mid. So we just have to do +1 here. Ooh, that's a little bit off. So I think that looks okay. I think the tricky thing is the equal case. In this case, we cannot do equal anymore, or we cannot assume equal to be in mid. So we just have to do this thing because then now we want tail to, now that we redefined it, head and tails are a little bit different. Yeah, okay. But then now we do head +1. Well, as I said, that's why these things are a little tricky. Okay. I think, even though I said earlier that I wouldn't do this, but I think for me to kind of help me debug this, I will do if nums is equal to mid is equal to target. Let's just return mid. And then now this should simplify the case a little bit better. Okay. Oops. Okay. So let's go through first principles again. Like I said, binary search are kind of tricky sometimes, even on very obvious ones. Okay, so we want the head to be inclusive, so now we don't have to worry about it. So let's just say this is our case. Let's say we're searching for 4. Well, 4, and we're pointing at the 5. Well, if we're pointing at the 5, then we want to continue. Well, the mid is bigger than 5, so then the tail will go to here, so that's right, okay. And then let's say if we go to 3, then actually want to move the head to include mid. So, okay, so this seems okay. But, yeah, maybe I just did the thing with the +1. Looks like I needed more practice, but why doesn't this converge? Oh, because if head is 0 and tail is equal to 1, it would never converge. No, that's not. Yeah, okay. Okay, for science, let's print it out so we could. My excuse is that I'm just waking up from, oh, not waking up. I just got back to New York, so it's my jet lag. But okay, so 0 and 1 for this is the second case. I guess that's what we expect. And with 0 and 1, the mid is 1, so it's gonna want the tail to be 1. So okay, so yeah, we definitely need this. The other way to do it is because if I do this, I don't think it converges either. The reason why I say stuff like that is because you need to figure out a way such that it always moves by 1 in each step, and in this case we don't really have that. So I think that's why it's been a while. So this has to be -1, and then this will be +1, but that's a little bit awkward. I think what I usually do in this case, and that's why I've been trying to avoid doing this, is just shift everything by 1 to make it a little bit more explicit, because basically the reason why is you end up with a number that's before the earliest number, where our definition makes it so that it always happens after the first number. So because of the way we structured it, we never check the first element. And this allows us to do it, but this is not that clean. I think what I would actually like instead is to shift everything by 1, so that you don't get this -1, which is a little bit harder to read, and +1 everywhere. But okay, well, I hope you had a better time than I did. Let's submit this just for, yeah. Okay, so that works. Yeah, a little bit rusty. I just got off 33 hours of flying and traveling, so that's my excuse. But that's why I always say, and that's why I always give myself the opportunity to practice binary search. There's little things like this that makes you really think about it, on why does it happen that you have an off by 1 on binary search, right? But as you do them more and more, the next time you do it, you'll be like, oh yeah, I remember the last time I did this is because I didn't search for the first element, so then I have to do, -1, or just or the index is +1 or something like that, right? So, or another way to do it maybe is just do another nums, like like nums as you go to negative infinity plus nums, so that your invariant holds that you always be behind one number, then it would be true. But so there are a couple of ways to handle these, and the ways that you want to get to is going to be you know, it's going to come from practice and practice and practice, and just going for these cases, right? Even as you see how I go for my cases, when you go for those cases, you're like, okay, so this is why, and then you allow yourself to kind of already thought about it next time. So when you see it next time, you're like, oh yeah, I did this before, right? So there's no secret, there's no tricky. I mean, it's you thought about it, just not during the contest, right, or during the interview. You thought about it a long time. That's what practice gets you. Cool. So this is binary search. This is clearly log n. Space is also O of 1. Leave me in the comments if you think I need to describe that more. But I am a little bit tired. I am a little bit jet lagged. So hit the like button, hit the subscribe button. Let me know what you think. Let me know how you did it. Let me know how did you handle the edge off by one edge case, because there are a couple of ways to handle it, and I did it this way. It feels a little icky, but as long as you're able to keep a consistent model in your head, it's okay. Anyway, hope everyone's having a good time, and I will see y'all tomorrow. Bye bye.